All right, so for those watching the video at home, I'm going to introduce it again. So we're talking about moles, okay, which is a cornerstone concept in chemistry. Now, we talked yesterday about how we figure out what the mass of a single atom is, or the mass of a single molecule, or the mass of a single formula unit. And that's great. And if we want to know water's formula mass, we add up the mass of 2 hydrogens and 1 oxygen. It's 18.02 atomic mass units. And that's lovely. That's really nice. The problem is that atomic mass units are not practical. Okay? We cannot go into the laboratory and measure so many atomic mass units of something. We can't put it on the scale and get a particular amount of something in AMUs. So, in the early 1900s, chemists started to look for ways to relate the concept of the atomic mass unit to a mass unit that was practical, specifically the gram. Because we can, in fact, go into the laboratory and measure a mass of something in grams. That's super easy to do, super practical. Now, based on the relationship between ratios and masses, chemists were able to establish the idea of the mole. Now, please pay attention. The unit mole has an abbreviation, and it's MOL. It's a whole 1 letter shorter. I'll take the opportunity to point out that the word molecule does not have an abbreviation, but the word mole has an abbreviation that's 1 letter shorter than its regular spelling. Would have been smart to not abbreviate mole and abbreviate molecule, MOL, but it's whatever. I didn't invent the chemistry. I told you guys that a million times. Okay? The only reason I point this out is because you will see this written like this often. I usually just go ahead and write the E. Like that's just how I do. But you will see this. This is not a molecule. Okay? It is a mole. If you need to write molecule, you have to write the whole word. There's no abbreviation for that. Okay? Now, I'm going to give you the definition of a mole. Please listen to my words. Do you remember, maybe you do, maybe you don't, but earlier in this semester I gave you the definition of a calorie. And I put it up on the screen. And the definition of the calorie, and you wrote it down in your notebook, was the amount of heat energy needed to raise 1 gram of water by 1 degree Celsius. It's like a sort of random arbitrary definition. Like, what does that mean? Like, what is that? Well, how much heat energy does it take to raise 1 gram of water 1 degree Celsius? Well, 1 calorie. Well, what's a calorie? Well, a calorie, it's like you're given the term is the definition, is the term, is the definition. It's like not really a definition. Mole is sort of like that, okay? So it's sort of a random arbitrary definition. I'm going to pick out some highlights. You need to write it down, and then we're going to do some highlights. Like there's some parts that you're going to need to underline, because when you see the definition of a mole on the SOL test, it's going to be in a very particular way. when you see mole on the SOL test, and you'll see it 10 times, 15 times on the SOL test, it's going to be its numeric equivalent. You're going to be doing math with it. You're not going to be talking about it. Okay? So the definition is sort of random and arbitrary. So here's the technical definition. Write it down. You got to have it in your notes, and then I'll give you some highlights in a moment. Now, a mole is defined as the number of atoms of carbon equal to the number of atoms in a 12-gram sample of carbon-12. Now, get your periodic table, find carbon. If you're looking at carbon, where does the number 12 come from? The atomic weight, which is the atomic mass, which is a mass number, yes? Okay, rounded to the nearest whole, it's 12.011 or whatever. Yeah, okay? So rounded to the nearest whole, it's 12. So that means that, let's refresh our memories, because y'all are having some memory trouble in general. I say that with love in my heart, okay? The mass number is found by adding what and what together? Protons and neutrons in that particular isotope, yes? The most common isotope of carbon happens to have 6 neutrons added together with 6 protons. The most common isotope of carbon has a mass of 12, yes? How do we know it's the most common? Because 12 is what's on here, yes? Now, does carbon exist in nature in another form? Yes. It's called carbon-14. It's radioactive. We use it to carbon date things like, oh, look at that cute fossil I found. It's 1.273964 billion years old. Well, how do you know that? Well, I asked it, and it told me. No, we do carbon dating. What is that? We look at the amount of carbon-14 that is left in there. We know its half-life, and then we calculate how old this mamma jamma is. Okay? But we're looking at carbon-14 when we do that. That is carbon that has 8 neutrons and 6 protons, so it has a mass of 14. You follow? Nod in the affirmative. Today is Tuesday. You are in chemistry. It's third block. Focus, people. Okay? So, 12-gram sample of carbon-12. Now, underline for me. Okay? Or maybe circle. Maybe better to circle. Circle the word mole. And circle carbon-12. Okay? When you see the definition of a mole on the SOL test, or the definition of a mole on my test, or on my quiz, which we're having one tomorrow, AT Dubs, the question is always something like, the concept of the mole was developed based on what element? Carbon-12. Do you follow? When you see a definition question, that's how it is. Okay? Otherwise, we don't really talk about the definition because we talk about the numeric equivalent. Now, what is the number of atoms of an element in 12-gram samples of carbon-12? If I have 12 grams of carbon-12 on my scale, it's sitting on the scale, 12 grams of carbon-12. How many atoms are in there? It is 6.02 times 10 to the 23rd. mole. We made it. Oh, he's missing a foot. Nope, there he is. We sewed these in class years ago. Calder Kegley. Oh, he just had twin babies. Will's wife did. Anyways, that's a mole. There's another mole up on the tip top of that cabinet. There's another mole somewhere else. Ooh, there's a mole on top of the mole box. See the box that says 6.02 times 10 to the 23rd? Underneath the thermostat. It's like a funny joke. It's like a funny ha-ha that you never got.
Yeah, that was up.
Okay, now, so you got mole problems? Call 602-1023. 6.02 times 10 to the 23rd.
Okay.
Okay, ha-ha, it's so funny. Okay? This, 6.02 times 10 to the 23rd. We're going to talk about this number a little bit more in a little while, so I'm not real stressed about it right now. But this number is huge. It's super important. Okay? If I send you to the store to buy a dozen donuts, how many are you going to bring me? 12, if you don't eat some on the way, but you're supposed to bring me 12. Okay? The word dozen means 12. Do you understand? It's a word that equals a number. Do you follow? Pie. Not pecan, not apple, not cherry. Pi is equal to what? 3.14. It is a word that equals a number. Do you understand? The word mole in science equals 6.02 times 10 to the 23rd. If I sent you to the store to buy a pie of donuts, I mean, that's silly, but how many donuts would you bring back? 3.14. If I sent you to the store to buy a mole of donuts, how many would you bring back? 6.02 times 10 to the 23rd. Do you follow? That would be, yeah.
Be okay with that.
Okay? So, mole equals 6.02 times 10 to the 23rd. Oh, heavens.
It's like something with 6.
Now, we're going to talk about molar mass. No, don't do that. Don't do that. I'm talking to the computer, not y'all. Okay. Molar mass would be the mass of what? A mole. I'm giving you some examples. We're just fleshing it out. We're just talking about it a little bit more, okay? If you have a mole of carbon, and we assume that it's the form that's on the periodic table, not some other isotope, okay? If you have a mole of carbon, that means that you have 6.02 times 10 to the 23rd atoms, and that means that you have 12.01 grams. Are you with me? I basically have just sort of written in a linear fashion what we already said, okay? Now, if I have a mole of phosphorus atoms, it will have a mass of 30.97 grams. Because I have a mole, I have 6.02 times 10 to the 23rd atoms. Because a mole of anything is 6.02 times 10 to the 23rd of it. You with me? Now, where did this come from? 4, the atomic mass for phosphorus. From the table? Yes? of water. That means that I have 6.02 times 10 to the 23rd molecules. Why did I use the word molecule instead of atoms?
It's a covalent.
Because it's a compound, because it's a covalently bonded substance, yes? Okay? It's not atoms. It's a molecule. Okay? We did chemistry to make the H2O. I have 18.02 grams. Where did this come from?
2 hydrogen atoms and 1 oxygen.
The mass of 2 hydrogens and 1 oxygen. What did we call this yesterday? Formula mass. And we wrote it in what unit yesterday? AMU. Please notice, this number, 18.02, this is the mass that we calculated yesterday. But yesterday we were talking about 1 water molecule. Literally, 2 hydrogens and 1 oxygen. 3 atoms total. 18.02 AMUs. If I gather together 6.02 times 10 to the 23rd molecules of water, it will have a mass of 18.02 grams. Are the numbers the same? Yeah. If it's formula mass, it's AMU. If it's molar mass, it's grams. Everybody put your pencils down momentarily. Pencils down. You're about to do this, like right now. The same homework. It's now work. Look at the first column, 1 through 5 on the left. Calculate the formula mass. All of those answers are going to be what? AMUs. And you're doing the same thing you did last night, yes? AMUs. What are you going to do for the second column, 1 through 5? The same thing, but instead of putting AMUs, you're going to put gram. It's the same. Do you understand? It's no different than last night. Formula mass, AMU. Molar mass, grams. The setup is the same. You'll have magnesium carbonate. You'll figure out the formula. However many magnesiums at this mass, however many carbons at this mass, however many oxygens at this mass, yes? And when you're done, you just put a G instead of AMU. Capiche? Now, write and then do. Hello at home. This concludes video 1 for today. Copy this. You have to back the video up, copy this, then do it. Then start video 2. Peace out.